Okay, so we're going to go through these two different distributions. We're going to do this sort of three confidence intervals. We're going to do them A and B independent of each other, and then we'll look at the difference that we just learned how to do and sort of look at how that whole process compares. So let's start with A. Let's start with A here, and I need some sort of fraction that represents our sample. So we're going to read through this again. Let's see. Of the 112 who received medication A, 84 said the pain relief was effective. So our p hat for A is 84 out of 112. And then I want to do plus or minus the z star for a 95% confidence, which is 1.96. And then I want the square root of, I'll do a fraction there, 84 divided by 112. Sorry, I'm going to multiply these two fractions together here in a moment. So 84 over 112 times 1 minus 84 divided by 112. Close that off, and then divide by the sample size, which is 112. Okay, so that means I'm going to pull up my calculator here. If I can get most of it on the screen. Alright, so let's first start with 84 divided by 112 is 0.75. Let's do the standard error next. So let's see, 0.75 times, well, okay, 0.75, 1 minus 0.75 is 0.25, but why not? I'll just type that in there, even though I understand it's 0.25. And then I want to divide that by 112. So I've got this inside fraction here, and then I want to take the square root of that decimal, and then I want to multiply that by 1.96. Okay, so that this piece is 0.75 plus or minus, was that 0.08? Sort of a rough estimate there. So I want 0.75 plus 0.08 and 0.75 minus 0.08. Okay, so that says that the confidence level is somewhere between 0.67 and 0.83 for A. Okay, then we want B. So let me ditch the calculator for a second. Okay, so for B, I want to do the same thing. Look for where it says 66 out of 108. So 66 out of 108 is my p hat, and that's plus or minus the same 1.96, z star, square root. We're going to do that fraction, and then parentheses 66 divided by 108, and then 1 minus 66 divided by 108. And then the sample size would be 108 for that. Okay. Kind of scroll this up so we can kind of see what's going on here. All right. So let me get the calculator back out again. All right, 66 divided by 108 is 0.611. And then I want to plus or minus what I'm about to find here in a moment. So I'll come back to the calculator. I want 1 minus that decimal, so 0.38. So that's the two numbers in the numerator here are the 0.61 and the 0.38. So then I just want to multiply those two together. So the numerator is 0.237. I'm going to divide it by 108. Then I want to take the square root of that. And now I want to multiply that by 1.96. Okay, so I get 0.092. Okay, so 0.611 plus 0.092 as, sorry, I'm going to do both those. Come back over here. 0.611 minus the 0.092. Alright, so 0.519 and 0.703. Okay, so let's take a, just breathe now that we've finished that calculation. Let's just compare the two intervals. A goes from 67 to 83, and B goes from 51 to 70.7. And so the question is there enough of a difference between the two intervals to say that there is a significant difference between them? And it's not about whether one is bigger or smaller than the other one. It's, is there any overlap? Is there anything in common? As long as there's something in common, then statistically I can't say there's a difference between the two medicines. So A and B have a slight overlap, right around 0.7-ish. Even though A is more above the 0.7 and B is more below the 0.7, there's still a few numbers where they overlap, and so just due to random sampling, as far as we can tell, they might both have the same population parameter. Therefore, I can't definitively say they're different. Okay. Now we're going to compare that to the two-sample procedure. So the two-sample procedure, I'm going to go down here, is this formula. So we have slightly more calculations to do. So let me get the relevant numbers down with it. Okay, so I need to start off calculating a P1 minus a P2. Let me get a field that I can sort of type in some numbers. I'm going to try not to hide the formula too much here. Okay, so let's remind ourselves of the two p hats. We had 0.75 and 0.61. So 0.75 minus 0.611 is that first piece in that formula. And then I want plus or minus. Okay, so sorry, this is going to have parentheses around it. Then I want, and we're still doing a 95% confidence interval, so that's 1.96. And then we want the square root of, and we're going to have a fraction plus the other fraction. And we're going to go fill in some numbers here. So let's see, we want p hat 1 times 1 minus p hat 1. So go back up here, that would be, that was 0.75 and 0.25 divided by 112. 0.75 times 0.25 divided by 112. Okay, and now I want p hat 2 and 1 minus p hat 2. That was 0.611 times, I think 0.39 is what I remember getting earlier. I can just look up here. Let's see, where'd you go? 0.389. And then the sample size of 108. Okay, so let me go back down. This is what we want to type in our calculator and actually get a confidence level. So 0.75 minus 0.611 is 0.139 plus or minus, and then this we're going to take a second to figure out here. So let's see, 0.75 times 0.25, and I divide that by 112. Alright, so it's that lovely number, that 0.016. Then I want 0.611 times 0.389 and divide that by 108. Okay, so then I want to add those two decimals we just found. So the 0.02, 0.002 and the 0.00167. We're going to add those up. So that's what's inside the square root. Then I want to square root it. And then I want to multiply that by 1.96. Okay, so that gives me 0.122. Okay, so if I do, now I get the parameters of the confidence interval. So 0.139 plus 0.122 gives me 0.261 on the high end, and then 0.139 minus 0.122 gives me 0.017 on the low end. Okay, now get rid of the calculator here. So in a two-sample proportion, so here's the big point, if there was a difference between the two, then I would expect to see, if there wasn't a difference, I would expect to see 0. And at this point, just due to decimal accuracy, we're really close to 0. Just kind of like up here, actually let me get that in the Word document. So that's down up there. So just like back up here, there was a slight overlap between the two. That is also close enough to having 0 in it that, as far as we can tell, there's not really a difference between the two intervals. But again, this is because I wasn't that accurate with my calculator, whereas up here I was very accurate, if I remember correctly. So the two processes sort of confirm each other when you're calculating out a two-sample proportion. Now this looks like a little more intimidating work on the calculator end, but I think it's a little bit less work than having to do that twice.